Okay, so we're looking at 6-3. This is about 3 days of material. So remember me saying that we only have 3 chapters to cover for the semester, which you might think that's not a lot. They're dense, okay? So that's why there's only 3. And I believe 6-3 is our last section before our mid-chapter 6 exam, okay? So your mid-chapter 6 exam is going to cover 6-1, 2, and 3. Not really sure. We'll probably take it like you're looking at Tuesday of next week. Okay? I don't want to say it's on a Monday. I hate Monday exams. So it'll probably be Tuesday. All right, so here are our goals for 6-3. We're writing trig functions. Notice it says of any angle. So what we've done so far is, let's see, recall. You can't really see that. Let's do this. Let me make this. There we go. So I want you to recall that the only thing we've covered so far was 30, 60, 90, or 45, 45, 90, right? That's all we've covered. Now we're going to learn how to find the trig function of, say, 25, 10, 70. You see what I'm doing there? So these are your special right triangles that we've already learned. These are the special right triangles. Now we're going to learn any type of triangle, any type of angle. We have a couple of vocab words to talk about first. In trig, we often think of an angle as a rotation. This is new, okay? You're used to, if I say an angle, you're thinking of just a corner of a shape, right? Now I want you to think of it as it's either rotating in one direction or the other. Okay? Look at these 3 examples right here. Now I know mine's color coordinated, so that may help a little. But this is a vocab word, initial side. The initial side of an angle from now on will be right here. This ray laying on the x-axis, that is your initial side. So I want you to think of it in terms of, like, if you're looking at me, the x-axis to the positive, this is the initial side, okay? So this ray stays put. The terminal ray, which is the one it's pointing to, is the one that actually rotates. It's the clock on an arm. I said that backwards. It's the arm on a clock that actually moves. You with me? So it's the one that's doing the rotating. The other one stays put. Initial side stays put. Terminal side is moving. It can only move in one of 2 directions. Clockwise, counterclockwise. Okay? And where it terminates the movement is called the terminal side. You with me? They're naming it in a way to help you. It's no longer moving, it terminated its movement, its rotation. Where did it land? We need to know what the quadrant numbers are. Okay, so if you recall, you have 4 quadrants, right? Those quadrants are the following. Let's see, do I really want to lay? I'll come over here. Well, I'll come over here. Draw an X and a Y axis. This is quadrant 1, 2, 3, and 4. Really important that you know those. Okay? Have to know those. Let me give you a corny little way to remember it, because it's not exactly intuitive. You look at it and you think, why did they label it like that?
Well, what type of numbers are over here in this quadrant? X is always what sign? If it's to the right, X is positive, and then if it's up, Y is positive. So these numbers over here are always positive, positive. So it kind of makes sense that you would start there. Okay, and then you might be thinking, well, why do they go this way? Remember, this is a coordinate plane, correct? This is a coordinate plane made up of the X and the Y axis. I want you to think of how you write the letter C. Watch this. Watch my pen. How do you write a C? You start up here and you go like that, right? Now, I definitely wrote over, so I'm going to come in here. You write a C like this. So I want you to think of labeling the quadrants as the same way that you write a C. So quadrant 1, 2, 3, 4. Now, here's another thing. Notice that a positive rotation starts with the initial side here, and then it rotates this direction. What direction is that, y'all? If it's going this way, that would run what? Clockwise or counter? If it's going this way. Counter, thank you. Y'all do have a little bit of a higher expectation to answer me because there's only so few of you in here. This is counterclockwise. Okay? A negative angle, initial side starts here, but then that terminal side drops down and rotates this way. So what direction is this called? Clockwise. This is clockwise. Let's see, I don't want to write it right there. I'll write it right here. This is clockwise. Now, you might be thinking, how am I going to remember positive goes counterclockwise, negative goes clockwise? Because it's kind of backwards, right? You would think positive's clockwise. It's not. They're backwards. Here's how I want you to think of it. Think of it in the same way that you're labeling the quadrants. I'm labeling the quadrants with positive numbers. So what direction did I just go? Well, you drew a C for coordinate plane, and I went counterclockwise. So this is how you're going to remember there's a lot of info here. This is what I mean by it's deep. These are positive numbers, and I'm going counterclockwise. This is how I label the quadrants. This is how I recognize that positive angles rotate counterclockwise. Then if I have that memorized, I know for a fact by default, then negative angles go clockwise. Now, a lot of people struggle with the terminals. The initial side is here. Which direction is clockwise and which direction is counterclockwise? Some people struggle with that. So if you need to, think of high noon. High noon is when the big hand and the little hand are straight up, right? And then clockwise, just start thinking about the direction the numbers are labeled on the clock. It's going this way. Now remember, that's negative, right? And then high noon going that way would be counterclockwise. You with me? There's a lot to take in there. You've got to make sure you have this right, or everything we're going to do is going to be wrong. So it will take practice. Hopefully these corny little ways will help you remember. Now, looking down at these examples, you'll notice that we have these examples up here and then these down here. What do you notice about these four compared to these four? What do you notice is different? Stay with me, don't go to sleep. What do you notice, y'all? These four angles compared to these four. There is a difference.
Bottom four get over 360.
I'll take it. What else do you notice? Notice where the initial side lands. Or the terminal side lands. This is saying, here's an angle that opens up and rotates 360 degrees. Doesn't even look like an angle, right? But because it has this arrow drawn, it's letting us know this is definitely a 360 degree angle. This one is saying, hey, it's going to open up to 180. This one's saying there's two angles here. You could do 90, or you could say negative 270. Notice they yield the same picture. Here, you could say negative 90, or you could say positive 270. These are actually called, these four, come on. These four examples are called quadrantal angles. Quadrantal angles. Sounds like a word they made up. It is an angle that is landing on one of the four quadrant axes. Quadrantal angle. The terminal side landed on an axis. So if you need to make that note, the terminal side landed on an axis. It's a quadrantal. Notice these four down here, the terminal side just landed out in the middle of a quadrant. There's no name for those. Those are just not quadrantal. Look, you can, and just like Garrett said, you can rotate more than 360. Right? I don't know, did y'all see the video from the X Games over the weekend, by the way? No? Somebody, I don't remember who the competitor's name was, but someone did a 2,340 degree turn on a snowboard. 340 degree turn. That's 6.5 rotations. It's insane. Look it up later. Google X Game 2,340 turn. Blew my mind. But anyways, I say that because we are now in the era of we can have angles bigger than 360. We can have angles that are negative. You might remember from geometry, they're like, you can't have negative angles. Yeah, you can. You actually can in pre-cal. We just told you that in geometry to get you through it. So now you can see that you actually do have negative angles or positive angles that rotate way more than 360. Okay, so let's move to the next slide. Stay with me. Now, here's the good news. This says find two positive angles and two negative angles that are coterminal with 51 and 71. So we need to talk about this vocab word, coterminal. This means they coexist and land in the same spot. So I'm going to come back over here. Here's a perfect example. How many angles did they demonstrate to us on this picture? Well, one of them was 90 and the other one was negative 270, right? There's two angles here. These are coterminal because if you open them up, they land in the same spot. So let's come right here. Coterminal means two or more. I'm going to put a plus sign because really it could be or more. Two or more angles that land in the same spot. When we say land in the same spot, we mean they have the same, the terminal side is in the same location. We mean terminal side is in the same location. So, same terminal side. sides because there's multiple. They want 2 positive angles and 2 negative angles. We have 2 parts here. Let's work with 51 first. 51 degrees, okay? Let's draw it. Where do you think 51 would land? Quadrant 1, 2, 3, or 4? You really need to get comfortable with all your quadrants. So like this is where it starts, right? This is the initial side. It's going to start here. Where is it going to land? Somewhere in quadrant 1. So this is 51 degrees if it was to open up like right there. They want us to give a positive angle that would land right here. How do you think I can get a number there? How can I get an answer? You're on the right track. 90 is not helpful because then that would be this right here. Remember, all the angles need to start from here. So we don't want to just open up to 51 again. What could I do? Think back to over here. Think back to all these. Could I go this way? How could I get that number? So think about it, if I had continued rotating and landed here, I just completed a full what, y'all? If I had continued rotating and landed right back where I started, what's that, y'all? 360. But I didn't, I stopped right here. So what's the gap that I didn't complete? The 51. So 360 minus 51 gives me what, y'all? 309. Now we went this way, correct? So if we rotate this direction, should it be positive or negative? Negative. So this would be, I'm trying to think of where I'm going to draw. I'm going to draw it right here. Negative 309 degrees would land you in the same spot. Now, that's one. It wants another one. That's a negative. It wants either another negative and then 2 positives. So let's keep this thought going. If I was right here on this terminal side, what if I did a full 360? So instead of rotating here and stopping, what if I rotated, I'm going to change colors, what if I rotated a full 360 and then stopped? How could I get that value? Add 51. I did a full 360 and then I did an additional 51. So we got 360 plus 51, and what's that give you? 411 degrees. So that's a full rotation plus some. Now they want 2 additional coterminal angles. 2 additional. What if we just do another rotation? So let's just add another 360. So let's do 411 plus another full rotation. And what do you get? How much? 779? 71. So if I was to sit down and to draw out 771, it's going to send me 2 360s plus the additional 51. And it's going to land you right there. So it's going to look like this. There's 360. There's 720. There's 771. So I'm landing in the same spot. Now, how do you think I can get another negative? Come back over here to the idea of this negative 309. That was me dropping this way and then stopping. Watch this. Drop this way. I landed here, so far that's what? That's negative 360, right? Because I went clockwise. And then I could keep going to land right there. Back up. Come on. Okay. So we've got negative 309. Let's just take another rotation off. Subtract 360. And what do you land at? Negative 309 minus 360. What do you get? Negative 669. All right. Now you might be thinking, why did that seem painful? Because first of all, it's your first time looking at it. Look, watch. Ooh, don't watch that. Watch this. If you have an angle that's opening up to right here, right? And we want to know what are all the possible angles that can land right here. The difference is simply full 360s. So we've got the original. Now let's just add 360. So circle 360. Remember, positive means counterclockwise. Circle 360 plus the original. I landed there, right? Another way to look at it is this. If this is where I landed, add 360. Won't I land right there? If I do a 360, if I'm facing this way and I do a 360, won't I land facing this way? Okay, the same thing goes with, like, if you have the spinner on a board game, if it lands in a certain spot and then you spin it and it does a 360, won't it land back in the same spot? That's the idea of a coterminal angle. So every time you're spinning it, it's just a difference of 360. Let's use easy numbers. Let's say this was 40 degrees. Add 360. Now it's 400, right? Now add 360. Now it's 760, right? That's the angle measures to describe landing here. Now go negative. Well, if it was negative, that's negative. So do 360 minus 40. What do you get? Do you get negative 320? Or, well, you subtract, yeah. All right, so this is negative 320. Now do another rotation. So add subtract 360 again. So you get negative 680. Subtract another 360. You can keep going and going and going. Okay? So when you look at this, it's saying, hey, what are the coterminal angles for 51 degrees? Give me 2 positive, 2 negative. All it is a matter of adding and subtracting 360. Now this one was painful because it was the first one and I wanted you to see the visual. Now let's look at it where you're just doing the math. We're going to work with B. B is negative 7. I need a coterminal angle that's positive and 2 coterminal angles that are negative. So first I'm going to add 360 and let's see what we get. What'd you get? 353. So there's a positive coterminal angle. We want another positive. This is a domino effect. Take that 353 and add another 360. What do you get? 713. Now that gave me 2 positive. I need 2 negatives. So let's come back to the original. Negative 7 degrees. Let's subtract 360. Rotate in the opposite direction. You get negative 367, right? That's going to land in the same spot. Domino effect. Negative 367. Take off another rotation. What do you get? What is it? Yep. So if you want to make a note to yourself, it's simply a matter of add and or subtract, depends on what they're asking for, multiples of 360. And when we say multiples, we mean you may add it once, you may add it twice. You may subtract it once, you may subtract it twice. So come down here, and I don't want you to find 2 of each. Just give me a positive and a negative for each of them. A positive and a negative. So 560. 560 is already past a full rotation, right? So if you think about it, 560 means, first of all, it's positive, so go counterclockwise. So it's definitely 360, right? And then think to yourself, how far is 560 from 360? What's the gap between them? 200. Okay, so if I keep going, let's break it up. This is 90, correct? This is 180. So then 200 would land about here, maybe. Does everybody agree? Because this is 90, this is 180, this is 270. So I went 360, and then I went an additional 100. So this angle is landing right here. This is 560 degrees. We need a positive and a negative. There's a couple of ways you could have done this. You could have said, all right, a positive, I'm just going to add an additional 360. And if you did that, what'd you come up with? 920? Right? That's correct. There's nothing wrong with that. I personally, I wanted to point out to you, sometimes the angle you're starting with is already past a full rotation. So just because you're looking for a positive doesn't necessarily mean you have to add. You could say, hey, I'm going to actually subtract off 360 here, and that gives me 200. Is that a positive coterminal angle? Yes, because the gap is just 360, and it's still positive. So this would have also worked. And then to get your negative one, you would have just said, whoops, I didn't mean to do. You would have said, I'm going to take 200 now, domino effect, and I'm going to subtract off another 360. And if I do that, now I get negative 160. All right, what'd you get here? Name your positive. Yep. Name your negative. Did you get negative 435? All right, what about 30? What's your positive? 390, right? Did you add 360? Did you subtract 30 from it?
No, I thought it was a -30.
Oh. And then if I want a negative, what do I do? What do I get, y'all? Thank you. Y'all got to tell me. Don't be embarrassed. Please don't ever be embarrassed. All right. This one's already negative, and it's already like past a full rotation in reverse. So we have a couple of different ways we could go here. If I wanted to kind of calibrate it back to between 0 and 360, I could add 360 here, and it's actually going to give me a negative coterminal. If I add 360, I end up with -90, right? Now, if I want a positive, then I could add an additional 360, and now I can see that, what is that? 270? Any questions on how to get a coterminal angle? All it is a difference of, think of a spinner on a board game. You're just spinning it in a certain direction to where it lands in the same spot. So you're either adding 360 or you're subtracting 360. All right. Now let's look at this. We're looking at two vocab words that you need to know. Complementary and supplementary. You may remember these from geometry. May or may not. Complementary means that angles, this is supposed to be an angle, hold on. It means the angles add to equal 90. Supplementary means the angles add to equal 180. Complementary adds to equal a right angle. Supplementary is adding to equal what's called a straight angle. Meaning, and the reason it's called a straight angle is because if I didn't tell you whether there was an angle here, you would think it's a line. Because it makes a line. But it's actually opening up. So you got to remember, we're no longer just talking about the corner of a shape. We're talking about a rotation. Now, here's a corny little way to remember this. Y'all ready? You're going to want to write this down. All right, here you go. C, complementary starts with a C, right? And then supplementary starts with an S. You ready? Watch this. I learned this from a student who remembered it from an 8th grade math class. Complementary adds to 90. Supplementary adds to 180. You see the difference? So a C can be made into a 9 and an S can be made into an 8. That's how you remember complementary adds to 90, supplementary adds to 180. Now, I'm a dork, and the way I used to remember, I never saw that. That's very creative. The way I remembered it was, it's silly. First of all, complementary is is it a smaller word? 2, 3, 4, 1, 2, 3. No, it's not smaller. I focused on the P. I told myself, think of a P as like a 9. This is 90, and then this is double. So 180. So that's how I used to do it until a kid showed me this, and I was like, that's genius. I love that. So this is now what I show students. I wish I could remember the kid's name. All right. So the idea is a complementary angle means they add to 90. So if I say, what's the complement of an angle? You're simply finding the gap of the angle to reach 90. So it would be 90 minus 71.46. And that's our complement, which would be 18.54, right? Degrees. Supplement would mean what's the gap of the angle to reach 180. So 180 minus 71.46. So that would be 108.54 degrees. So this is the complement. And then this is the supplement. This is the angle needed to get it to those specific 180 or 90 values. So come down here. You have 4 practice problems. Tell me the complement and the supplement of each. If you want, you can abbreviate like C for complement, S for supplement, and then just find them. You'll notice that on my guided notes here, I tend to add extra problems. It'll say extra examples. This is kind of a difference in college math. You'll notice that they give you fewer examples and expect you to understand it in those few examples. I personally was not that kind of kid. I needed more examples. So I tend to put extra examples in our notes just to make sure you really understand it. So tell me, what is the complement of 20? 70. Nice. The complement of 20 is 70 degrees. What's the supplement? 160. Yes. What's the complement of 63? And then what's the supplement? Ethan, what'd you get? 117. Nice.
117.
Nice. All right. Complement of 38.6.
26.
Nice. And then the supplement, Jocelyn. Nice. Complement of half a degree. Thank you. Reagan, supplement of half a degree.
179.
Nice. This is a lot, so I really don't want to move on to the next thing. Especially with one of you not here, like, I feel like this isn't too much to try to catch him up on. If I go further, it's going to be a lot. So